question number 5. So 3 blocks of different masses, okay, 3 blocks of different masses M1, M2, M3 are placed on a smooth surface as shown in the figure. Now you're asked to find the contact force between M1 and M2 indicated by F12 and the contact force between M2 and M3 indicated by F13. So you need to find out the value of F12 as well as F13. So before solving, let us try to find the acceleration of the system. So clearly, as the force is applied from left side, okay, behind M1, no doubt all the bodies will be pushed right side. So the acceleration of the complete system will be towards right side. So we know that the acceleration of the system A is equals to the net force acting on the system to the total mass of the system. So A is found to be F net. What is the net force acting on the system? F. And what is the total mass of the systems? M1 plus M2 plus M3. This is the acceleration of the complete system. But you're asked to find out the contact force between M1 and M2, this indicated by F1, F2, and the other is the contact force between M2 and M3 indicated by F13. Okay, so let us try to find out them. Okay, so first of all, let me try to find out F13, then I'll move to F12. Children, if you would like to find out F13, so because of this force F13, what body is being accelerated, was set into motion? Only M3 was set into motion. So this force, contact force F13, pushes the M3 the other side towards right. So clearly we have from the figure F13 must be equals to mass into acceleration of that system. Which mass? Only this block is being pushed. So M3 mass into A. So F13 is found to be M3 times of the value of A is taken from the above equation as F by M1 plus M2 plus M3. So the value of F13 is found to be M3F by M1 plus M2 plus M3. That's it. Okay, you're also asked to find the value of F12. So let us try to find the value of F12. In order to find the value of F12, identify, so this force, contact force, I'm acting on how many bodies? 2 different bodies. This force pushes both the blocks towards right side. Okay, so F12 is equals to the how much mass is being pushed? Both blocks, that is M2 plus M3, the total mass into acceleration of the system. So this F12 is equals to M2 plus M3 times of acceleration of the system is how much, children? It is F upon M1 plus M2 plus M3. Hence, as they asked us to find the value of F12, so F12 is found to be M2 plus M3 times of F by M1 plus M2 plus M3, whereas F13 is found as M3F by M1 plus M2 plus M. That's it. Okay, so shall we move to the next question? That is 6th one. A horizontal force of 500 Newton pulls 2 masses 10 kg and 20 kg. So lying on a frictionless table connected by light string. What is the tension in the string? You're asked to find the tension. T here, see, tension is there because these two are connected with the help of a string. So some tension is created in the string. You're asked to find out. Okay, what is the tension in the string? Does the answer depend on which mass end, mass end the pull is applied? So that means one thing you need to observe, children. So here 10 kg and 20 kg are attached by a string. Here also 10 kg and 20 kg are attached by a string. But in this case, the force of 500 Newton is applied on 20 kg. Whereas the second case, 500 Newton force is applied on 10 kg. So this is at the end of 20 kgs, first picture, at the end of 20 kgs, the force is applied. In the second picture, at the end of 10 kgs, the force is applied. So, ask you to find out whether the two forces are same or different. Does it matter or not? Okay, does the answer depend on which end the mass it is been pulled is applied? Okay, let us try solving the same, children. First of all, let us try to calculate for picture A, case 1, picture A. Okay, if you observe that, what is the acceleration of the system, children? So here, as it is being pulled, 500 Newton is being pulled towards the right side. Okay, so from this we can conclude that the acceleration of the system is equals to force upon net force upon total mass is your general formula. So this acceleration is found to be, what is the total force applied here? 500 newtons upon total masses. These two masses, how much? 10 plus 20, it is 30 kgs. So solving this, we have 0 and 0 gets cancelled. Hence the value of acceleration A is found to be 50 upon 3. Acceleration of the system was found to be 50 upon 3. We can even solve this, the value of acceleration. After solving this, we can write it as 3 ones, 6 threes, 18. So something like 16.66 meter per second square approximately. Okay, but you're asked to find the tension in the string. So in the case, tension in the string can be calculated as T1 is equals to, this tension pulls only 10 kg mass, so T1 is equals to 10 times of mass into acceleration. Mass is 10 kg and acceleration of the system is, just now we calculated. So how much is that? 10 into 16.66, or T1 is found to be 166.6 Newton approximately. So the tension created in the string is found to be 166.6 Newton. Case 2. If you go with the case 2, here we go. Okay, case 2. Tension in the string, acceleration. First of all, let us try to find out the acceleration of the system. As the force is being attached to the 10 kg and pulls towards left side, the complete system will be accelerated in the which direction, children? Towards left. Accelerated towards left. Okay, so acceleration of the system is again your net force upon total mass. So what is the net force acting on the system? Net force is again 500 Newton, whole upon total mass is 10 kg plus 20 kg is again 30 kg. So solving this, 0 and 0 gets cancelled. You got the same answer, that is 50 by 3. 50 by 3 is nothing but 16.66 meter per second square. Same value. So acceleration is found to be 16.66 meter per second square. But you're asked to find the tension in the string. But the tension was indicated with the letter T2. Well, so now focus on this T2. This T2, this tension force is pulling only 20 kg towards left side. So T2 must be equals to mass into acceleration. Mass is 20 kg into acceleration, 20A. So 20 times of, what is this? 16.66. So this value is found to be 12, 13, 3, something like this. So we have 333.2 newtons. So earlier we have only 160.6 newtons, but here we got it as 333.2 newtons. So you're asked to find out, does the answer depend on which end of the mass the pulley is being applied? Of course it depends, because so if the force is applied on 20 kg mass, the answer we are getting it as 166.6 Newton. If we apply the same force on 10 kg mass, you are getting the tension in the string as 333.2 Newton. So makes a lot of difference. So it matters. Okay, children. So moving to the next question. 7th question. A pendulum bob of mass 50 grams is suspended from the ceiling of an elevator. Your elevator means imagine it as some lift. Okay. So there is a lift, something like this. from the ceiling, a pendulum bob is being suspended, whose mass is given. Okay, you're asked to find the tension in the string for the different cases. For the first case, the lift is going upward with some acceleration. Second case, going up with some deceleration. Third case, moving with uniform velocity upwards. Okay, next downwards. So like this, different cases have been asked. So let us try to solve all. Okay, so find the tension in the string if the elevator is case 1. If you observe, when the elevator is going up with some acceleration of 1.2 meter per second square. So first of all, let us try to drop the free body diagram. In order to find the case 1, okay, free body diagram for this is, we need to consider the mass M whose weight is acting downwards, and tension for the first case, let me name it as some T1, first case T1, and it was given that it goes up with acceleration. So goes up with acceleration. Acceleration means A is taken as 1.2 meter per second square. So based on that, we need to solve the tension. As it is moving upwards, equation of motion is upward force minus downward force is the net force, or T1 is equals to minus mg. If it is brought the other side, then it will become plus mg. mg plus ma. So take out m as common, then you are left with m into g plus a. mg plus ma, take out m as common, you are left with g plus a. So m into g plus. So T1, substituting the values, mass itself is given as 50 grams, convert into kgs, 50 into 10 power minus 3 kg. Gravity value, we take it as 9.8 meter per second square, plus it is moving up with an acceleration. How much acceleration was given, children? Acceleration was given as 1.2 meter per second square. So substituting the value of acceleration, we have 1.2 meter per second square. Okay. Acceleration is given as 1.2 meter per second square. That's it. Well, so after solving this, we have T1 is equals to 50 into 10 power minus 3 into 9.8 plus 1.2 is how much is this? 11. Okay, hence the value of T1 is 11 into 5 is 55. So 55 into 10 power minus 3, we can write it as 0.55. So we got it as 550 into 10 power minus 3. So minus 3, bring the decimal over here. So you'll be getting 0.550. Simply it is written as 0.55 Newton. So whenever the lift is moving upwards with acceleration 1.2 meter per second square, we got the tension in the string as T equals to 0.55 newtons. Okay, we shall move to the second part of the question. So next condition, it was asked to find out whenever the lift is going up, same case, but with a deceleration of 1.2 meter per second square. So second case also, the lift is going up, but now the value of A is given as deceleration. So deceleration now means instead of 1.2 meter per second square, we need to take it as minus 1.2 meter per second. So going ahead, so second case B, let us try to imagine the free body diagram whose weight is acting downwards. Tension second case, let me take it as T2, lift is going upwards. Okay, but deceleration is A is taken as minus 1.2 meter per second square. This you need to make a note, children. Earlier it was acceleration, now it was deceleration. Deceleration means minus value. So solving this, again as the lift is moving upwards, equation of motion is written as T2 minus mg must be equals to ma. Minus mg, bringing the other side, we have T2 is equals to m into g plus a. Substituting the values, T2 equals to m is 50 into 10 power minus 3 into g is 9.8. minus 1.2 meter per second square. That's it. Hence, T2 is found to be 50 into 10 power minus 3. 9.8 minus 1.2 is something like we have 8.6. Okay, so how much you're getting, children? We got it as something like 8.6. Hence, the value of T2 is found to be 0.43 newtons. Okay. So T2 is found to be how much? 0.43 newton. That's it. Earlier going up, here also going up, but earlier it was going up with an acceleration. Now it is going up with a deceleration. Hence, deceleration means tension acting will be little reduced. So now focusing on the third part of the question. In the third case also, the lift is again going up. The elevator is again going up with uniform velocity. Children, whenever a body moves with uniform velocity means what is the acceleration? 0. So same constant velocity means acceleration, not at all accelerating. Acceleration is 0. Okay. A equals to V minus U by 2. V equals to U. Okay. Final and initial are same. So A is 0. So in the third case, A is given as 0 because it is moving with uniform velocity. So let us try to solve the third part of the question. So case 3. So let us again imagine the lift here also going up. All the three cases are all regarding going up only. So it is accelerating upwards, mass M, weight mg. Third case, let me name the tension as T3. But here acceleration is given as 0. So 0 meter per second square. So again acting upwards means equation of motion is written as T3 minus mg equals to ma, or T3 is equals to m into g plus a as usual, all the three similar cases. Hence the value of T3 is equals to 50 into 10 power minus 3 into g value is 9.8 plus a is 0. Hence T3 is equals to 50 into 10 power minus 3 into 9.8, or T3 is equals to, so we got it as 9.8 into 50 as 49. So we have 0.49 newtons. How much is that? So earlier lift going with some up with some acceleration, up with some deceleration, up with uniform velocity or 0 acceleration. So now next case, that is now the later case, fourth case, it was given that the elevator goes down with some acceleration of 1.2 meter per second. So the same question, but now the condition has changed. It is now moving downwards. Downwards with an acceleration. How much acceleration is given as 1.2 meter per second. So substituting these values and imagining the condition. So I'll be plotting up the lift here, children. So this is your pendulum, downward motion, tension T. That's it. So let us try to solve the same. Case D. So in this case it was given that mass M, weight mg downwards, tension, fourth case let me name it as T4, but it is accelerating downwards with a value of 1.2 meter per second square. So writing the equation of motion as it is moving downwards, downward force is greater than the upward force. So we have mg minus T4 must be equals to ma, or bringing the minus T4 the other side and carrying the ma, you will get m into g minus a will be the value of T4. So T4 is equals to m is 50 into 10 power minus 3 into G is 9.8 minus 1.2. Hence T4 is equals to 50 into 10 power minus 3 into 9.8 minus 1.2 is something like 8.6. So this is the value 50 into 10 power minus 3 into 8.6. Hence T4 is equals to 0.43 newtons. So whenever the lift moves downwards with an acceleration of 1.2 meter per second square, the tension created in the string is found to be 0.43 newtons. Well, so let us move to the fifth part of the question, children. So case E, the same lift goes down with deceleration of 1.2 meter per second square. So the same lift, same bob, tension again going downwards, but in this case it is given as deceleration. Deceleration means we have to take the value of A as minus 1.2 meter per second square, minus deceleration. So substituting those values in the above equation, we get the value of, so first of all, free body diagram, this weight is mg, tension T upwards, mass m, accelerating downwards, whose value is taken as minus 1.2 meter per second square. Okay, so we have the equation of motion. Downward motion means mg minus t equals to ma, minus t bring this way and ma the other side. We have m into g minus a is the value of t, or t is equals to mass m is taken as 50 into 10 power minus 3 into g is 9.8 minus I wrote it again, instead of a I have to replace it minus 1.2. So this minus and this minus will become plus. So plus 1.2. Hence the value of t is something like 9.28 plus 1.2 is like similar to the first one. 50 into 10 power minus 3 into 9.8 plus 1.2, you'll get this value as 11. 11 into 50 is 55. Okay, 550 into 10 power minus 3, you will be getting it as 0.55 newtons. So whenever the lift moves downwards with deceleration of 1.2 meter per second square, the tension in the string, name it as some T5. The tension in the string created will be 0.55 newtons. So now the last part of the question, children. So going ahead, F. So moving to the next case. What is that? The lift is going down with uniform velocity. The same case but lift is now going down with velocity. Uniform velocity means acceleration of the system is 0. So dropping the free body diagram, weight is acting downwards, tension 6 upwards and mass m, it is moving downwards with 0 acceleration. So writing the equation of motion, we have downward motion, downward force is greater than the upward force. Mg minus T6 is equals to ma. Bring the T6 the other side and ma here. So m into g minus a will be equals to T6. Or T6 is equals to, the value of m is 50 into 10 power minus 3 into 9.8 minus 0, because it is moving with uniform velocity, so a is 0. Hence the value of T, tension in the string, is found to be 50 into 10 power minus 3 into 9.8. So 0 acceleration means 50 into 10 power minus 3 into 9.8, whose value is found to be 0.49 newtons. So these are the different cases that are possible with the lift: upwards, downwards, acceleration, deceleration, uniform velocity. All models are being covered, and hence the result. Okay, children? Well, so moving to the next question. Question number 8. A block of 2 kg is suspended from the ceiling through a massless spring. Till far we solve the numericals based on string, but this thing you need to focus, children. So now it was given something different. It is spring. So I told you while explaining the concept only, whenever spring is there, the force acting is given as minus F is equals to minus kx. So larger the elongation, larger the force applied, larger will be the elongation. So spring force will be larger accordingly. So I'll explain this. This is the spring, children. Okay, because of some force F is applied, the lift will be extended to some distance x. Okay, as a result, the restoring force will be applied on this. The restoring force given as spring force Fs is equals to proportional to x in the opposite direction. Okay, F is equals to larger the force, larger will be the elongation. So larger will be the spring force, or Fs can be written as some constant into x minus kx. If F equals to applied force, F equals to kx, spring force will be minus kx. That thing you need to understand. So we know the formula F. The spring force is given by minus kx. Larger the elongation, larger will be the restoring force. So proportional to that in the opposite direction. So this should come into your mind whenever the concept of spring is given. So anyhow, mass of the block is given as 2 kg. Okay, spring constant K is given as 100 Newton per meter. You're asked to find the elongation of the spring. Okay, that's it. This is the first part of the question. Again, we have the second part of the question. We shall think about it later. Another 1 kg added and all. We'll discuss it later. So anyhow, solving the 8th question, we have, here we go. So as we know that F is equals to minus kx. Okay, how the force is being applied, children? So this is your spring, and for this spring, a block of mass 2 kg suspended through a massless spring to a ceiling. The spring constant K is given as 100 Newton per meter. Okay, as we know that F is equals to minus Kx. F means upward direction force. Okay, or minus F, you can say minus F is equals to Kx. Like this also you can write. Anyhow, whatever be the case, let us only try to find out the magnitude of the force. This is given by simply Kx. Magnitude of the force is given by Kx. So no foreign object is been pulling it downwards or anyhow. Only because of the mass attached, because of the mass attached, because of the weight, the force here is weight. Because of that weight only, the spring is being elongated. As a result, the restoring force will be acting. So the only force present on the spring is the weight of the object. So instead of M force, I can replace it with mg is equals to, actually it should be minus kx, but only magnitude I am considering. So mg is equals to kx. So ask you to find the elongation of the spring. Elongation of the spring is nothing but extension of the spring. So what is the extension of the spring? Some x distance. So x is equals to mg by k. The elongation of the spring is given by mg by k. What is the mass attached, children? To the g value. Okay, take it as 10 is better because k is given as 100 Newton per meter. Okay, solving this, we have 0 and 0 gets cancelled, 2 goes by 5 times. Therefore, the value of x is, the elongation in the spring is 1 by 5, or x is equals to 0.2 meters. So the elongation created in the spring is found to be how much? 0.2 meters. That's it. Simple, children. F is equals to kx or x is equals to mg by k. You know all the values, substitute to find out the elongation in the spring, the stretch, how much it is being stretched. So moving to the second part of the question, if another 1 kg is attached to the block, so already this 2 kgs is there, along with this what they are doing is, so 1 more kg is being attached. So now the total weight acting downwards will be 3 kg. Okay, so the total weight is 3 kg into g, that is 3g. So based on that, what would be the further elongation? So further elongation will be some x dash. So new force will be created. So let me name it as f dash is equals to k into, because of extra force, extra elongation is being created. Okay, magnitude of the force I'll take. So magnitude of the force is, what is the magnitude of the force? 2 masses are attached now. m1 plus m2 into g is equals to k into that elongation. Okay, so what is the mass here? First mass is given as 2 kg and the next mass is extra 1 kg into g, let me take it as 10, equals to 100 into x dash. Okay, or x dash is equals to 3 into 10 upon 100. Okay, so solving this, we have this and this gets cancelled. So the value of x dash is found to be how much, children? It is 0.3 Newton. So x dash is equals to 0.3 meters. So earlier elongation, only when 2 kg mass is suspended, the elongation was found to be 0.2 meters. But now the new elongation was found to be 0.3 meters. But here in the question it was asked how much further it is been elongated. From 0.2 meters to 0.3 meters, what is the extra elongation? Extra elongation, if you are asked to find out, means it is nothing but delta x you are asked to find out. Delta x is nothing but x dash minus x. So the elongation is x dash is 0.3 minus 0.2, or it is extended by further of 0.1 meter, and this must be your answer. Okay, so you people may get confused and you may stop your answer here until 0.3. No, you are asked to find out. So earlier some elongation is there, extra how much elongation is being created in the spring. So this is 0.1 meters.